All right, guys, let's get going. So these are, for the most part, just going to be either, like, rewrite and put in the calculator or just straight up put in the calculator. So, ooh, my screen's in a weird mood. I just got it sideways. Oh, I can't actually see all the buttons. So the first one was log of 45. So we just come over here and we can hit log. If it'll... Why won't you let me touch these? Oh, wow, too many logs. Ah, that's fun. My computer's being a jerk. I love it. It won't let me use the screen, and it won't let me use the iPad, so I'm gonna have to figure out where my mouse is. There we go. So let's do log of 45 and get a decimal answer, 1.65321. So log of 45 is 1.65321 or something like that. To the 10,000th means we take 10th, 100th, 1,000th, 10,000. Right here is where we truncate or round. Since that's a 1, the 2 stays the same. So log 45, we just type in the calculator. Log base 4 of 256, I can't put it in the calculator like that. We've got to use our change of base formula. Which means...
There are two words
not
spelled like
you.
wait.
Oh
Wait
my gosh.
means.
Siri is not helpful. We're going to use that change of base formula, which I had on the top of the screen for us to see, where we're going to switch it to have the common logs button that's on our calculator, and we love buttons on our calculator. Which number is going to go on the top, the 4 or the 256? The 256. And then on the bottom, we have log of 4. To get the numerical answer, we try really hard to let my computer do the thing and not. So we just type those in on the calculator. So we're going to come, where's my mouse? There it is. I'm going to clear it. Ooh, it's not even going to let me click this time. It's not letting me do things. Oh my gosh, my computer's being such a jerk about it. So hit your fraction button. Oh, now it goes. Of course, that's super helpful. There we go. Fraction button. It's right there. Just once. Yeah, that's what I thought. Just one time. Holy cow, laggy. We're going to do our log of 256 on the top. Yay. Over log of 4. Boop. So our answer is 4. So log base 4 of 256 is 4. That's our answer here. Using that information, using that change of base, we can do 3 and 4 pretty easily. I do it without having to wrestle my computer for control. So again, we're going to put these into the change of base formula. You should have gotten log of 15 over log of 2. When you type that in the calculator, what do we get as a numerical answer? 3.
0, 6, and then 9. That's rounded up to.
Sweet. Because it would have been 6, 8, like 7 or something like that.
6, 8, 9.
Perfect. And the very bottom one on here, we do log of 2 over log of 6, which gives us numerically what's our answer.
2, 3, 8, 6, 9.
9. Okay, change of base It's just a way to get it to type in the calculator. Because our calculators don't have alternative bases in an option. Questions on these ones? Okie dokie. Oop. What my computer gives me lots of things. Alright, so we are gonna figure out what that other weird LN button is on your calculator today. So we're gonna be on page 425. These are called natural logarithms. They don't look particularly natural, but that's what they're called. And it's gonna pull up a teeny tiny little piece from last chapter that we used a fair bit in our exponential functions. We just haven't talked about it at all. Because we got a new one of those letters that actually means a number things in our exponential growth. Think about when we did our continuously compounding kind of stuff. And we had that little bitty variable, that e to the x. Yeah, e. He's going to come back. E is a number, just like 3, just like pi. It's a number. It's the only thing, we just write a letter in place of writing 2.7182818. So if we wanted to solve and get this the variable out of this exponent, where we would take the log on both sides, the reason why logs exist, this would give us a base of e. Base of e happens frequently enough in like higher mathematics that they gave it a name. So we didn't have to write log base e a gazillion times. It still means log base e. Like log, ooh, that's not a pen. Log base e is the exact same thing as the natural log, which you write as ln. We don't have to put a base on it because a natural log only has a base e. They are 100% exactly the same. ln is log base e. And that's for the most part what this whole page is talking about. It's going to start talking about solving stuff where we're trying to pull exponents or variables out of exponents using logs. That's going to be some of the things we're going to use today, is solving with these. But that's what this whole page is saying. It's also giving you a little quick sketch here of an e to the x function. Remember, that's our like savings account stuff. The longer you leave it in there, the bigger it grows. And the inverse function, so I can figure out how much time it's going to take, is over there. So what we're going to do is we're going to rewrite things into log and natural log form. So I am going to take that off. Because what we're going to do is we are going to rewrite this BPA log BAP. That's what we're in right now. Our BP equals A. That's an A, not a 9. Log base B of A equals P. That's what we're doing here. It's just got e's as our base. So rewriting this in logarithmic form, for part A here, we're going to have log base E of whatever the heck this thing equals, 14, equals that power, which is x. Well, we just talked about on the last page that a log base E is also written as ln. So I can take this chunk here and replace it with ln of 14 equals x. your calculator has an LN button, it is common enough that there exists a button about it. So I can go onto my calculator if my computer's not being a jerk. Clear. It's gonna be really hard for a minute. I am tapping clear. This button right here. So we had our log button up here. The one right below it, it says LN. You can hit that. Let's see if I can get my computer to do it because it's being such a jerk right now. This button right here, this is our LN, and it's not going to do it for me. Because of course not. Of 14, and you can type that in. What is ln of 14? 2.61 ish. Is 2.64. Because I got 2.639057333. So it gives us another option. So we don't have to necessarily use change of base formula. We can, if we have a log base E, I don't have to do log of 14 over log of E. You absolutely can. You'll get the 100% exact same answer if you want to. So let's do the same thing for B. First things first, we're going to write it as a logarithm. So we're switching this around, BPA log BAP stuff. So we're going to have our log with a base of E of X equals 7. Again, we found that log base E. So we have the ln of something equals 7. This one we can't type in the calculator because we've got a variable in our log. But it's good practice to switch them around. Okay, questions on this part of rewriting them around? You can start using your calculators here, but mostly it's just rewriting the same way we've been doing before, with the addition of the fact that ln is a thing that can happen. Okay. Because we're going to do the same thing the other way. Oh, no, we're doing the check. Sorry. So try these two. I'll give you 2 minutes. Let me see if this is going to work for me now. No, it's still not working. Why is this still not working? Ew. iPad's being a jerk. Okay, so all we're supposed to do here is put these in log form. What did you guys get? equals 3. And remember, log base e is also written as ln. That's our natural log. ln of 4x equals 3. These two pieces mean exactly the same thing. Log base e of 4x and ln of 4x. But otherwise it just looks like log e. All right, how about B, the one on the right? What do we get? Log base e of 3 is 4x. How do I switch this into natural logs? ln of 3. Yep. ln of 3 is a number. This right one, I could 100% get a numerical answer for it. That's going to be ln of 3 divided by 4. You could type that in a calculator. We could get to a solution there. I could get an answer. That is something we type in the calculator. Now we're going to go the other direction. We're going to take them in these log forms and we're going to put them back in the exponential. So this is page 426. And I know it's got little spots for you to write, but I feel like it's a whole lot easier if I write the whole thing and we do it that way. So we've got the ln of 9 equals x. So the natural log of 9. And the first thing I want to do when I'm switching these around, the easiest way to switch them around until we get the hang of it is to switch it into log base e. And then my argument and my power stay exactly the same. ln is log base e. Those are the same piece. So once we have it here, we can use our BPA log BAP in order to switch it around. So we're going to have my base is e, my power is x, and that's going to equal 9. So ln of 9 equals x is the exact same thing as e to the something is 9. They mean the same thing. Y'all got to stop turning your volumes up the second I sit down. I know y'all think I can't hear it because I'm still sitting, but I can. Every time I stand up and walk, magically the volume goes down. Shock. Just because I'm not standing next to you doesn't mean I can't hear your headphones playing. It's really rude and distracting to those around you. Because if I can hear it, you bet your neighbors can hear it. Just saying. It's rude. Just because you don't care about passing this class doesn't mean everyone around you doesn't care. Just saying, because that's what you're telling me when you crank your music the second I sit down, is that you do not care about this class. So if you don't care, why should I care about your grade? Just lying. I can't care about your grades more than you guys do. Okay, so this one, it looks weird, part B, but it's the same exact thing. We're going to switch our ln to be log base e of something equals 1.7347-ish. And we're going to switch it around into our exponential form. So our base is what? E. What's our power? The 1.7347-ish. That's what the squiggly equal sign here, that means about equals. That means they rounded somewhere. Equals our x. That we could get a value for. E to the something I can type in a calculator. I could get a number here. I could get x is this. It is a thing that exists. Okay, so switching them back and forth is kind of the first step in the process of using these to solve stuff. And I want you to try it, just like we did the last time. Take 2 minutes. Switch them around. All you're doing is switching them around. All right, what do we get for A as this in exponential form? What's our base? Not the next step. What is the answer? E to the 4th is 3x. Because, yeah, I agree. My next step would usually be to write this as a log base e, but I want us to get all the way down into our answer. How about part B? What do we get? What's our answer for this one over here? E to the, not to the 4th, to the 3x equals 4. My equal sign looks funky there, but that's okay. We're going to fix it. Be careful. If it helps, every single time, write out our BP equals A log base B of A equals P. Write it out. It's there to help you. It's the same process. What we're going to do now is we're going to start using this to solve some stuff. And we're going to be working on solving for the rest of this chapter. Like, that's the rest of what we're going to do is we're going to be using logs to solve stuff. And what we can do here is we can use our condensing or we can use our calculator. I mean, the calculator can do some of it. That's the way that they're kind of doing it. But we're condensing. So what we're going to do is we're going to condense. It's the same exact stuff as when we did it with logs. When we condense, our first step, making it smaller, we're going to have our powers, or we're going to have our multipliers or our coefficients are going to become powers. I'm going to switch that to be coefficients because otherwise I'm going to use m twice. Coefficients become powers. What's next in our process of condensing? Do you guys remember? If the coefficients come up and become powers, I was going to say we have our multiplication. I can't remember which one we did in which order. The multiplication, and we have our subtraction becomes division. Which, we're doing subtraction first. So our subtraction becomes division, and our addition becomes multiplication. There we go. Coefficient to powers, subtraction to division, and addition to multiplication. I'm going to block out this so I can actually write things down. So, looking at our expression up here. What are we going to do first? The coefficients. What coefficient do I have? What do I have that's a multiplier? The 1/3. The 1/3 is going to go up and become a power. So we're going to have the natural log of 8 to the power of 1/3. Nobody else has a coefficient, so they're just kind of plopping in. Natural log of 3 plus natural log of 9. We could simplify that. 8 to the 1/3. We could type that in the calculator. 8 to the power of 1/3. Oh, yeah, or the cube root of 8. So this is the same thing as the natural log of 2 minus the natural log of 3 plus the natural log of 9. So our next step when we're condensing, what do we do? The subtraction becomes division. So I have a minus sign right here. That means I'm going to divide my two terms. So we're going to have the natural log of 2 divided by 3. The whole point is to have fewer logs there. Plus the natural log of 9. What's our next piece? The addition becomes multiplication. So we're going to have our natural log of, I'm going to put parentheses here so we can simplify it. 2/3 times 9. What is 2/3 times 9? What is it? 6. Yeah. Natural log of 6. What is the natural log of 6? Say it again. 1.79. Ish. Right, because it didn't hit exactly. It gives a weird log, forever grossly number. So I'm going to put this squiggly equal sign. It about equals 1.79. It's 1.79-ish. So natural logs, these LNs, we can treat them exactly the same way as a regular log. We can condense things in it. We can solve things with it. We can play with things around in it. We can type it in the dang calculator. Okay? Natural logs are just log base E. They just get a fancy name because mathematicians be extra. Pretty much. Okay, so what we're going to do is we are going to have, obviously, the rest of the time to work on this, and we will work more with solving stuff come Friday. So things we did, we're up through number 23. So this is all stuff you can do. The last 4 are things we have done. You can also do 34 and 37. 29 and 31 you might be able to figure out. Maybe. Actually, no. We're not going to do 34, 37. Let's wait till Friday to do those two. Okay. So Friday we're going to talk through the rest of our solving stuff. Monday, we're going to work through some story problems. Tomorrow is SAT day. So if you are a junior, you will be here taking your SAT right now, tomorrow. If you are not a junior, catch up on your dang homework. I have too many friends that have too little homework in. I have a whole lot of friends missing at least something. I have very few friends that have turned all the homework in. Just saying. So if you're one of my rare few that do have all your homework in, or you get it all in and are kind of on a roll, go work on Alex. I would rather you do your homework than work on Alex. However, you are always welcome to do both. Homework is 4 points. Alex is for not. Alex is for helping you kind of understand either skills we passed and we're not super strong on, or skills we should have learned in previous courses that we're not super strong on. That's what Alex is designed to do. It's going to help bridge those gaps that we've all kind of developed in the last couple of years. So our chapter test is next Friday. Next Friday. I will be printing reviews out later today, so you can have them on Friday. If you're one of those work on the review over the weekend people. If you're real pressed to start on the review tomorrow, hop back by later today. I'll have them about 5th period. Okay? But that is all I got for you today. You have about 10 minutes until announcements. Almost. So start working on the homework. Yeah. A lot of them you could probably do writing it in this book and just hang on to the values when you do it on McGraw-Hill. They don't take a ton of space, the ones we did today. Okay, so work on stuff. Ask questions. We are here to help.